Welcome to the overview for Chapter 6. In this chapter, we begin with a simple extension of the area under the curve. We look at finding areas between curves and really take advantage of the Riemann sums. We fine-tune our areas by making sure we determine which functions are greater and which are less. Finding the intersection of these curves will be helpful. In section 6.2, we look at volumes. The first set of volumes will be the volumes of revolution. We will examine volumes and find appropriate ways to slice them. The slices will generate disks with thickness that will be our delta x's. These will be our Riemann sums that we will add up and transform into an integral. Some of the volumes of revolutions will have holes. In these cases, the slices will turn out to be washers. These washers are simply disks with smaller disks taken out. Identifying the radii will be key. Along the same lines as volumes of revolution, we find volumes by slicing. A non-rotated volume can often be sliced to get a non-circular shape. If we make our slices with common shapes, we can add them up, and these slices will delta x thickness. Then the Riemann sums will turn into integrals. Back to volumes of revolution, we sometimes run into solids that might not slice neatly. In some of these cases, a simple slice may not be ideal. We introduce the shell method. This method looks at a strip of area that is rotated. This forms a shell, a cylinder with a thickness. These shells are stacked up and will form a solid. There are a lot of real-life shapes that can be made with a cylindrical shell. Section 6.4 applies integration to physics. We will first look at Hooke's law, where we determine a spring constant by how far a spring stretches with some mass. Then we look at pulling things up a building through a pulley system. One of the extended problems in the textbook talks about how much work it took to build a pyramid. Then we'll talk about how much work it takes to pump water out of containers. This will generally depend on the shape of the container. Our last section will take a look at an application to statistics. When we find the average of a set of numbers, we add up and divide by the number of numbers. We can find the average of a continuous function by similar methods. Remember that when we add up an infinite number of things, the Riemann sum becomes the integral.